Good day everyone, I am Tisha and I'm Colindres of PS Bio 11 and I'm going to discuss about the functional group carboxylic acid. Carboxylic acid occupies the center place among the carbonyl groups. They also serve as the starting material for preparing numerous carboxylic acid derivatives such as acid chloride, esters, amide, and thiosulfides. Carboxylic acids have higher boiling and melting points compared to other compounds of comparable molecular weight. They are also soluble in organic solvents of the same size. The UPAC nomenclature of carboxylic are identified by a suffix added to the parent name of the longest chain. Change the ending of the parent group into OIC acid. For example, this 6-carbon chain. This is hexane. Change the E into OIC acid. And this will become hexanoic acid. How about if we put a substituent? Just like a normal naming of functional group, let the OH group be the lowest, so let's start counting from here. 1, 2, 3, 4, 5, 6. We will name it as 4,5 dimethyl and add the hexanoic acid. Some interesting carboxylic group includes propanoic or propionic acid, butanoic or butyric acid, pentanoic or valeric acid, hexanoic or caproic acid, octanoic or caprylic acid, nonanoic or pelargonic acid, decanoic or capric acid, dodecanoic or lauric acid, tetradecanoic or myristic acid, and hexadecanoic or palmitic acid.
Good day everyone, I am Herlin Hope A. Maglunob, a student from BS Biology 11. A ketone is a functional group with the structure R2C equals O, where R can be a variety of carbon-containing substituents. Ketones contain a carbonyl group. The simplest ketone is acetone, with the formula CH3CCH3. Many ketones are of great importance in biology and in industry. The common names for ketones are formed by naming both alkyl group attached to the carbonyl, then adding the suffix ketone. The attached alkyl groups are arranged in the name alphabetically. Ketones take their name from their parent alkene chains. The ending E is removed and replaced with 1. The general formula of ketone is CnH2O, where N is the number of carbon atoms. The simplest ketone is of 3 carbon atoms, so its formula will be C3H6O, called as propane. It can also be written as CH3O or CCH3. The carbon of the ketone is counted with carbon of the hydrocarbon.
Good day everyone, I am Mayan S. Angeles from BS Biology 11 and today I'm gonna discuss the functional group aldehydes. Any organic compound in which a carbon atom has a double bond with an oxygen atom, a single bond with a hydrogen atom, and a single bond with another atom or group of atoms are called aldehydes. Aldehydes include glucose and other so-called reducing sugars, as well as various natural and synthetic hormones. Now, let's proceed to the structure of aldehydes. The carbonyl group is connected to two hydrogen atoms in formaldehyde, the most basic aldehyde. The carbonyl group is like to one hydrogen and one carbon group in all other aldehydes. Carbon atoms attached to an aldehyde's carbonyl group can be from saturated or unsaturated alkyl groups, as well as alicyclic, aromatic, or heterocyclic rings. Let's now tackle the nomenclature of aldehydes. Aldehydes can be named in one of two ways. The first method, known as systematic nomenclature, is based on the methodology adopted by the International Union of Pure and Applied Chemistry, or the IUPAC. Parent alkane is assumed to be the longest chain of carbon atoms containing the carbonyl group. By altering the suffix E to Al, the aldehyde is revealed. There is no need to use a number to pinpoint the carbonyl group of an aldehyde because it can only be at the end of the parent chain and hence must be carbon 1. Because the longest carbon chain in 4-methylpentanol has 5 carbon atoms, the parent term is pentane. The suffix Al is added to indicate the presence of the aldehyde group, and the chain is numbered starting at the carbonyl group. Because it is attached to the 4th carbon in the chain, the methyl group is assigned to number 4. The other technique of aldehyde nomenclature is to call them after the common name of the equivalent carboxylic acid, that is, a carboxylic acid with the identical structure of the aldehyde but for the presence of COOH instead of CHO. Acids are typically given names that finish in IC acid.
As for the next functional group, I, Mary Reyetal I. Tamba of BS in Biology 1-1, will talk about the esters. Esters fall within the category of oleochemicals, meaning they are naturally derived chemicals rather than synthetic. An ester is a compound that is formed from a condensation reaction that occurs when a carboxylic acid and an alcohol is combined. Therefore, the exact combination of the type of alcohol and the type of carboxylic acid will determine which ester will be produced. The carbonyl group bonded to an OR group. Both the IUPAC and the common names of the esters are derived from the names of the parent carboxylic acids, and the alkyl group is named first, followed by the name of the carbonyl group, which the suffix "ane" is replaced by 8. Now, there's two parts that you want to focus on. The portion that has both oxygens, including the carbonyl group, and the other part. Esters have 2 oxygens and it contains 1 carbonyl group. This is the first part. Notice on the right, we have 3 carbon atoms. 1, 2, 3. On the left, we have only 2. Now, the 3 carbon atoms on the right is named propyl. And the 2 carbon atoms on the left is an ethane. Now change the suffix "ane" to "OH". That would be ethanoate. Now when we put it together, the ethanoate must come to the end. Therefore, it would be propyl ethanoate.
Hi, it's Ayla here from BS Biology class. And today, I'll discuss to you about amides. Before we proceed, let's recap some general details about the functional groups. So, functional groups are a group of atoms responsible for the characteristic reactions of a particular compound. It is important in chemistry because they are the portion of a molecule that is capable of characteristic reactions. And they determine the properties and chemistry of many organic compounds. So, what is amides and its further function? Amides are functional groups in which a carbon-carbonyl atom is linked by a single bond to a nitrogen atom and bonded to two other groups, either a hydrogen or carbon atom. It is named after Rudolf Adrian Wehrmann, who discovered it in 1910. In general, it is an organic reaction in carbohydrate chemistry in which amides are degraded by sodium hypochlorite, forming an aldehyde with one less carbon. So here are some sophisticated understandings about amides. Here are some examples of amides containing structures. Like esters, solutions of amides in water usually are neutral, neither acidic nor basic. The amides generally have high boiling points and melting points. These characteristics and their solubility in water result from the polar nature of the amide group and hydrogen bonding. Do you know that amides can be primary, secondary, and tertiary? So here is the example. So what is the IUPAC name for this particular amide? So we have a total of 3 carbons in which associated with the word propane and drop of E and add amide at the end so that it will be propanamide. That is all about for our topic amide, and thank you for listening.